We got a fun one. We got a really fun one. All right, so let's factor. And this one's going to get a little bit crazy. It's going to get a whole lot crazy. X minus 2, X minus 2. What in the world? And then factor out the GCF here. We're going to have 2 and then X minus 2. And that's going to cancel out. And it's going to leave off. It's going to leave off with X minus 2 over 2. And that's only going to be true where X is not equal to 2, which means we do have a hole in this graph, right? So there is a hole in our graph, and it's at 2, because that's what canceled. Now, you might be looking here, and yeah, you would be right to look there as well, noticing that these are the same factor, right? Okay, so we're going to have an issue. We'll deal with it. But X minus 2 equals 0, which means X equals 2, so 2. The parenthesis isn't dangling anymore. And I'm going to plug in, this is fun. I'm going to plug in a 2 here. So I'm going to have 2 minus 2 over 2, which is going to give me 0. So the hole is at 2, 0. Now, before I draw that, I want to make sure, because there's some craziness happening. And again, it happened because we have the same thing twice. So before we plot the point, let's just keep going. Vertical asymptote is where the denominator equals 0. Oh, that didn't happen. So there is no vertical asymptote. So all the graphs we've drawn up to this point that are like, oh, look at that curve, they don't cross those lines. Not going to happen here. Just saying. Horizontal asymptote. And let's go back to the beginning for this. You don't have to, but you could. Because once you stare at this long enough, you'll realize what we're really dealing with. It's really neat. So this one is pretty basic, actually. This has a degree of 2. This has a degree of 1. I want them to have the same degree, so I'll force them to have the same degree. So I'll put a 0 there. And dividing the leading coefficients gives us 1 over 0. Well, 1 over 0, yeah, good luck with that. You just punched a hole in the fabric of the universe. So there is no horizontal asymptote either, because you can't divide by 0, right? All right, that brings us to x-intercept and y-intercept. So what we're going to do is set, it's about to get crazy. We're going to say 0 equals this numerator, which means x equals 2. And you're tempted to put a hole at 2, right? Put an x-intercept at 2. You can't. There's a hole there. And now things get really fun, because we got to start talking about the fact that this factor happened twice. So even though I see that and I'm tempted to be like, I'll put a dot right there. No, I can't. This hole is more important than what would exist, because I can't plug in a 2 here. So this is indeed a point that I should open circle plot, and I will not put this. So no x-intercept. And if you're like, but I found one, there's a hole there. We found it. It was the same location. Okay, y-intercept, let's just cheat again, cover up your x's. 4 over negative 4, you could also do it here. You could say y equals 0 minus 2 over 2. That's going to give me negative 1. So same thing here. And you're like, well, I don't know what this thing looks like. You bet your butt you do. Your butt? What's a butt? I don't know. All right, I'm going to take this and go one more step with it. 1 over 2 is 1/2 x. 2 over 2 is that. It's a line. This is slope-intercept form. It's where x is not equal to 2. Okay? So let's draw it. Y-intercept is negative 1. Slope is 1/2. Open circle there. That's it. We have here we go. We have a discontinuity, a removable discontinuity at x equals 2, because that's where the hole is.